Mwalimu Theophil Academy reminds you that success is not an overnight process, but consistency. Welcome for today's session.
Let us start solving various examples concerning with Faraday's first law of electrolysis. Example 1. How long should a current of 5 ampere be passed through a solution of silver chloride in order to deposit 3.24 kg of silver metal at the cathode? You are given electrochemical equivalent of silver is 1.118 times 10 raised to negative 3 gram per coulomb. Now, let us see the way we may solve this question. Here, let us start with a solution. After writing the solution, let us analyze the data which we have. Data given. In this question, we are given the current. We are given current electricity I, which is equal to 5 ampere. Also, apart from current, we are given the mass of silver deposited. It was mass of silver deposited. M is equal to 3.24 kilogram. Also, we are given electrochemical equivalent of silver. Electrochemical equivalent of silver. Electrochemical equivalent of silver. And you have to know that electrochemical equivalent is symbol is Z of silver is equal to, we are given 1.118 times 10 raised to negative 3 gram per coulomb. These are the data we have. And what is asked here? We are asked to find the time, as the question asks, how long should the current of 5 ampere be passed through a solution of silver chloride in order to deposit 3.24 kg of silver metal at the cathode. Now, how long will that time is required? Time is required. Time T we are not given. So we are required to find the time for this mass of 3.24 to be deposited when the current of 5 ampere will be passed through an electrolyte of silver chloride. Now, let us see the way. Here, according to Faraday's first law of electrolysis, we are told that mass of silver deposited is equal to electrochemical equivalent times current times time. This is according to Faraday's first law, that the mass liberated at or dissolved from the electrode is that proportion to the quantity of electric current passing through the particular electrolyte. Now, after there, here what we are looking for is the time. If it is the time, it means that to get time from this equation will be equal to mass over electrochemical equivalent times current. But you have to remember that here the given electrochemical equivalent is in gram per coulomb. So even this mass as it is in kilogram, so to make them as this mass is in kilogram, it should be changed into gram so as to match with a given electrochemical equivalent. Now, for the case of mass, we are going to multiply this 3.24 kilogram times 1000 so as to make it to be in gram. So here we are going to substitute these values. In terms of mass, we are going to put 3.24 3.24 times 1000. When we multiply by 1000, we change the kilogram into gram. Here, let us divide by electrochemical equivalent 1.118 times 10 raised to negative 3 times, this is the electrochemical equivalent, times electric current, which is 5 ampere. Now, let us divide. Let us use a calculator to compute this mathematical term. We have 3.24 times 1000 over 1.118 times 10 raised to negative 3 times 5. Here the answer we get is 5.7961 times 10 raised to 5. You have to remember this is time, so it is in second. In second. So this is the answer. When we approximate it, we get almost 5.8 times 10 raised to 5 seconds. Now, it will take 5.8 times 10 raised to 5 seconds for the mass of 3.24 of silver to be deposited at cathode. Now, this is the required time for it to be deposited. Apart from using the formula directly obtained from the Faraday's first law of electrolysis, we have also an alternative for this question. Let us see an alternative. So we say, alternatively, we may solve it as follows. Alternative. The alternative method which we use here is to use a balanced chemical equation. As we know, the electrolysis of silver chloride at the cathode, it means that silver ion will be deposited. Now, if silver ion is going to be discharged, it means that it is going to be reduced. Now, silver ion is going to be reduced at cathode and it becomes silver metal. Let us see its equation. Reaction at cathode. Reaction at cathode. It means that silver ion is going to be reduced. It means that it will regain the lost electrons and it becomes a silver metal, which is in solid form. Here it is in aqueous. So this is a balanced chemical equation for the reaction at cathode, whereby silver ion is going to be reduced, as you may see. Now, from this balanced chemical equation, we can use the mole concept to get the relation between the used moles of electrons and the deposited amount of silver. Now we say that from this equation that one more of electrons is equivalent to 1 mole of silver metal. As you can see, it means that when 1 mole of electrons is used, the 1 mole of silver solid is deposited. Now let us see, from this relation, we may also compare it. If you remember, 1 mole of electrons is equivalent to 1 Faraday. Now, if 1 mole of electrons is equivalent to 1 Faraday, it means that instead of writing 1 mole of electrons, I can write 1 Faraday. Now it means that 1 Faraday is equivalent to 1 mole of silver metal. Also, when I say Faraday, 1 Faraday, you have to remember, is equal to 96,500 coulombs. Now, I can change these Faradays into coulombs. I mean, the quantity of electricity in terms of charge. So here, it is 1 Faraday, it means that it is 1 times 96, it is 1 times 96,500 coulombs. Will be equivalent to 1 mole of silver. But also, you have to remember that 1 mole of silver is equal to 180 grams. So, instead of writing 1 mole of silver, I am going to write 1 508 grams of silver. Why have I changed it to mass? I have changed it to mass so as to compare with the given amount, which is in terms of mass. Now, let us see the way we do. So, 1 times 96,500 coulombs is equivalent to 180 grams of silver. Now, you may ask, let us use the data from the question. Here, it means that we are given 3.24. These are in terms of kilograms. So to change it into gram, we multiply by 1,000 to make it into gram. Now, this amount, this is the amount deposited at cathode, will be equivalent to how much coulombs. Here, we are required to convert the given current to relate the given current and time so as to make them to be in coulombs. So to get the coulombs from the question we are given, it means that we are going to take the current times time. It will be 5 times t, as t is to be calculated. T is not known. So when you take the 5 ampere we are given times the time taken, it means that we are going to get the charge in terms of coulomb, which will match with this one from the standard balanced equation. Now, after there, what is required? We are looking for t. To get t here, let us cross multiplication. When we cross multiplication, we can be in the position of obtaining a known value of t, which is asked in our question there. 5t will be multiplied with the 108. So it will be 5t times 108. It will be equal to, also, 1 times 9600 will be multiplied by 3.24 times 1000, as you see. Here we are going to get the values. Let us start by multiplying 5 and 108. 5 times 108. We are going to get 540 t. As t is not known, you have to remember it at the time. Now we are looking for t. It will be equal to, let us multiply also this. Here is 1 times 96,500 times 3.24 times 1000. Here we are going to have 312,660,000. Now, what next is to divide by 540 both sides so as to obtain a known value of t, which is our required time. Now, it will be 540 t is equal to 312,660,000. We divide by 540 both sides. 540 both sides. Now we are going to get t. What is the value of t? T will be equal to, let us divide. Now on this side we are going to cancel out 540 are going to cancel out. Here we are going to remain with the t. Now our t will be equal to 312,660,000 over 540. You have to know the answer obtained here will be in terms of seconds, as we are looking for time. Now let us divide that value. We have 131,660,123 over 540. Here the answer which you get is 5.79 times 10 raised to 5 times 10 raised to 5 seconds. When you approximate this, you get 5.8 times 10 raised to 5 seconds. Now you can find that the answers are the same. The answer which you obtained in the first approach is the same as when we used the balanced chemical equation. Now, this is the way we carry out the calculations concerning with the Faraday's first law of electrolysis. So here we say that the current it will take 5 0.8 times 10 raised to 5 seconds for 3.24 kilogram of silver to be deposited at cathode. This is the answer which is required for this question. Now, I hope you have gained a lot. On the way, we solve various problems concerning with the Faraday's first law of electrolysis.